Hello, everybody. Good evening and welcome to this evening's education event. And big apologies for all the technical issues we've had all along. We really appreciate everybody's patience with it. And I guess this is just the way things are at times, but we really appreciate your patience with it. My name's Declan Rowan. I'm a family doctor. I'm a chief of hospice medicine in Pembroke Regional Hospital. I have a community family practice in Ottawa as well. And I'm one of the members of the regional acute care team, and I'm here to moderate the talk tonight. We're going to get going very shortly, but I'm delighted to welcome Dr. Majewski to talk to us tonight about COVID-19 vaccinations. Very popular topic tonight, and I think this is the largest turnout we've had for one of these events, so we're really delighted that everybody has joined in. Throughout the talk, if you do have questions, you can put them in the question and answer box or the chat box. We'll try and keep on top of them, and we'll ask questions as we go along as well. So just to a quick introduction to Dr. Majewski. He was trained in infectious disease at the University of Ottawa. He's happily settled into clinical practice at the Queensway Carleton Hospital. He's passionate about high quality and compassionate patient care and improving access to care in infectious diseases. He's always happy to chat and support his colleagues and is president of the medical staff at the Queensway Carleton. He tells me if he wasn't working in infectious diseases, he'd probably be in a canoe guiding a portaging trip through the Algonquin Park with his 10-month strapped to the front and his 4-year-old strapped to the back. Sounds pretty attractive. Maybe not today in the winter, but I could take that in July, maybe. So welcome, and thank you for your patience tonight. We're looking forward to tonight's talk. Thank you.
Thank you very much for the warm welcome. I trust you can hear me. Okay. Yeah, Dr. Rowan, you can hear me?
Yeah, loud and clear.
Very good. Okay, thank you everybody for attending. I apologize for the delay on my part with technical difficulties from the hospital here, but a warm welcome to all of you, to my colleagues. This talk is titled COVID-19 Vaccination 101, but it could be 202 and 303 and 404. There's a lot of information here, which I'm happy to share with you. We're going to walk through it together. The talk is essentially divided into two sections. The first is a presentation more of data, and I try to keep it as factual as possible without editorializing. And then the second part opens things up a lot more for discussion. We're obviously in a very difficult time in many ways with this pandemic, and the rate at which we're being thrown information has only accelerated recently with the rollout of all of these different vaccines, and they are rolling out one after another. So we're going to cover a lot of ground today, and we'll try to keep it fairly light and as cohesive as we can with lots of input from you. I don't have any disclosures. I have been involved as a sub-investigator in several clinical trials for COVID therapies, but nothing to do with the pharma industry per se, and certainly nothing to do with the vaccines. In terms of the objectives, we're going to talk about the virus and review some of the pertinent virology of SARS-CoV-2, so we're on the same page when we talk about the vaccines. We're going to speak about some of the emerging variants and their role in how they affect vaccines and how they affect the future. We're going to review some of the leading and approved vaccines, and also we'll speak about the use of these vaccines that have been approved in Canada in special populations, and as well the ones that have been approved in other places to some extent. And then the second part is really discussing several important topics and controversies as they pertain to COVID-19 vaccination. You'll notice this is not a talk on the vaccine rollout, and I know that's a whole separate set of stress, and we're looking for information there, and certainly we can talk a little bit about the logistics of that, but really the focus of this is to understand the vaccines and the pertinent details around them and the big questions. So I get questions about COVID vaccines all the time these days. I've had a number of phone calls from pregnant colleagues, from people who have pregnant family members. I've had the big questions thrown at me at the hospital. What is all this going to play out like? What is the future going to look like once we're vaccinating people en masse? And we're going to bring some of those points home. I know there are frequent questions about vaccination and pregnancy, so we'll focus on that a bit more as well. So first, let's get a little bit intimate with the virus, because we need to understand a few things. So this is SARS-CoV-2 depicted in the graphic on the left-hand side of the screen. It's a single-stranded RNA virus. It's a coronavirus, of course. It has several surface proteins that we are interested in, most particularly the spike glycoprotein. The spike glycoprotein is critical for the virus to infect human cells. Without the spike protein, the virus is completely unable to do so. And the other graphic kind of shows you a different schematic, three-dimensional recreation of this spike protein. And the spike protein has several important domains, and the receptor binding domain is one of the critical ones in which it attaches to our cells. And so the spike protein, being so important to the virus, readily accessible on its surface, is a popular target of the first round of vaccines, and especially the early front runners. Now, SARS-CoV-2 variants, of course, have come into the news in recent months and continue to come into the news. As I'm making this presentation, one of the challenges was to not miss anything even today. Even today, there were a few things that are included in the presentation, so it's as up to date as I could hope to get it. But essentially, what you have depicted in front of you is the amino acids of the spike protein that we just looked at. And there's 1,273 amino acids in the spike protein. And the schematic below shows the evolution of some of the mutations, including the popular or predominant, I should say, variant strains that we're seeing now, including B117 in the UK, B1351 in South Africa, and what's called the P1 variant that's predominantly in Brazil. It's an alphabet soup, but if we look at the other side of the graphic, we start to see how some of these mutations are affecting the virus in a big way, and in turn affecting our susceptibility to infection and possibly effects of vaccination. So a lot of these viruses share certain mutations as variants that give them more fitness. The N501Y mutation, for example, increases the binding affinity of the virus to human cells. The E484K mutation, which you don't see in the UK strain, but you see in the South African and Brazilian variants, is to some extent impairs neutralization and recognition by antibodies, at least in the lab and in immunogenicity studies, but also clinically we're seeing some effects of that. And even in the last week in the US, there's been quite a bit of media coverage, as you have at the bottom of your screen, about the California variants, in particular one 429 and a hybrid form, as well as in the last couple of days the New York variant. And again, these variants, like the others, there are concerns about their ability to infect humans. In other words, their contagiousness and how readily they cause infection, as well as will they be as well covered by the vaccines that are coming out, because they do have these spike protein mutations. And some of these mutations, as I mentioned, change the spike protein, so our immune system may not recognize it as readily, or at least certain arms of our immune system may not recognize it as readily. So before we go into the vaccines, the other thing I wanted to chat about is the concept of acquired or natural immunity and herd immunity. And of course, you know, you can get immune to infection by getting it, or by getting vaccinated to it. And of course, when you get the real deal, the question is, how long do you maintain good immunity? How long are you protected from reinfection? And obviously, we know from experience that many respiratory viruses do not give us robust, long-lived, natural, or acquired protection. And the data on COVID-19 or SARS-CoV-2 is still evolving, but the data that we have so far, again, we've only been at this for over a year, suggests that natural infection is generally protective. We see antibodies in studies persisting at good high titers for 6 or 8 months post-infection. And if we look at what we've been seeing clinically, confirmed reinfections within the first year are rare. If you look at some of the data there, they're in the 50 to 100 range, although if you look at suspected reinfections, where we don't have necessarily lab confirmatory data, depending on where in the world they're happening, that number's pegged somewhere around 11,000. Still, when you look at the volume of infected people we've seen in the world, that is quite low. Now, if we use seasonal coronaviruses as a correlate, which cause colds, and we've seen them for many, many decades and long time and have experience with them, the data seems to indicate here that protective acquired immunity is short-lasting, somewhere in the realm of 12 months or less. And again, that's not surprising because we get colds and respiratory infections from the same groups of viruses year in, year out. So is that going to be the case with this virus, which after all is a coronavirus? So until recently, again, we weren't seeing a huge rate of reinfection, but putting the pieces together with these variants, there's a concerning situation that developed in the city of Manaus in Brazil, which you may have read about, which questions whether herd immunity or natural immunity is something that is ever going to happen as the virus mutates. And essentially what happened in Manaus was they had a very bad COVID outbreak last year around April, May, bad in the sense they were dealing with hospitals running out of oxygen, rammed with patients, and in fact, digging mass graves. So very, very sad situation. And then the infection rate went way down and people loosened their guard, and studies were published suggesting that they may have actually reached herd immunity based on blood donor sample analyzation, showing that maybe even up to 75% of the population had been exposed based on modeling. But in December, they suffered a second wave, which is ongoing and is just as bad, if not worse, than the first in terms of numbers, in terms of severity of disease, and in terms of fatalities and overwhelmed hospitals. And what they're seeing is that there's a variant now, the P1 variant, that is the predominant strain, which was not present in analysis from the first wave. And so, there are several hypotheses put forward to explain this situation. One is that the herd immunity numbers in the modeling studies were quite overestimated, although people don't really seem to believe that in the field. The second, of course, is that this P1 variant is evading our adaptive immune mechanisms from the first wave of infection. And then the third is that, generally speaking, our naturally acquired immunity is waning. They are about 7 to 8 months from that first wave when they're seeing the second. So these are the kind of hypotheses being put forward, but certainly the concern that there are variants coming forward that are evading the immune system is at the forefront. So to kind of put things in perspective about herd immunity a little bit further, so there are several perceived big downfalls of pursuing natural herd immunity. And of course, one is the human cost. You can certainly say let everybody in the population get infected, but you're going to, unfortunately, have a lot of death and a lot of morbidity. So that's unacceptable. The second point is what I mentioned earlier, which is how durable is that natural or acquired immunity? How long does it last? Are we just setting ourselves up for failure? And then the third, of course, is the increased opportunity for viral mutation just by sheer volume of cases, which is the issue even today. Is we just have such a high number of COVID circulating that, of course, that accelerates and increases the opportunity for error as the virus replicates. and introduces a higher risk of mutation and more variants. COVID-19 doesn't mutate as rapidly as HIV or even influenza. The data puts it somewhere at a quarter of HIV and half of influenza in terms of mutation rate. It does have a built-in riboendonuclease that helps to repair mistakes as it replicates, but we're seeing such a high number of cases, and not surprisingly, the virus is adapting for fitness and infectivity. So that's where vaccines enter into things. Can we quickly ramp down these numbers? Can we shut down this virus? Can we stop transmission? And of course, can we stop severe disease? So we're going to talk about a summary of the leading COVID-19 vaccines. I'm going to show you some efficacy data. We'll talk about safety, and we'll talk about use in special populations. I really like this site. If you're looking for an easy read that keeps you up to date in what's happening in the COVID-19 vaccine world, the coronavirus vaccine tracker on the New York Times is an excellent site. And they publish all kinds of good information, some of which I'll share with you today. It's up to date, it's updated daily. Here you can see how many vaccines are in development and at what stage. And this is really unprecedented, right? We get one vaccine for a disease. We don't get at a time. We don't get two, we don't get three that make it to market. This is really an unbelievable effort, and we're getting a lot of early successes. There have been some failures. As you can see, some vaccines have been abandoned after trials, but as per February 23rd, we had 4 vaccines approved for full use and 7 vaccines in early or limited use, and a lot more coming down the pipeline, including a few Canadian ones, which we can chat about a little bit. So when you look at these vaccines, here's the list. The first 2 you'll be the most familiar with because they're the only 2 that are approved for in a limited fashion or for emergency use and approved in Canada. And that's, of course, the Pfizer and Moderna mRNA vaccines. The third one to the party was actually the first one to the party, which is the Sputnik 5 from the Gamaleya Institute. And we'll talk about that one as well. It is in use in multiple countries. And of course, Oxford AstraZeneca has had a lot of media coverage because it's easier to store, it's cheaper to produce, and it's more widely accessible to most of the world and has been rolled out more broadly. I want you to notice one thing here, and that is that all of the vaccines I mentioned, including the next couple like Johnson & Johnson and Novavax, are all targeting the spike protein. So we're really trying to gut punch the virus in one spot. If you look at towards the bottom of the list, which doesn't necessarily mean it's the bottom in terms of efficacy, we see a number of vaccines from China and a number of inactivated whole virus vaccines, which of course is a different mode of attack or mechanism to attack the virus. And the knock against these, of course, has been just the lack of release of clinical data and the variable accounts of efficacy from different countries as they're being rolled out, but we'll talk about them a little bit. So let's go to the number 1. So this is the Pfizer-BioNTech Fosun Pharma conglomerate got together for this vaccine. It has a large lettered and numbered name in studies. It has a trade name, which is Comirnaty, and it is a messenger RNA vaccine. How does it work? It's a lipid-based, for stability, nanoparticle containing viral mRNA that specifically encodes the entire spike protein, and the viral target is the spike protein. It's given in 2 doses. It was studied as 21 days apart, although we'll talk about that as well. And at the bottom, I show you for these vaccines that have been approved where they're being used. And the green is full approval, and the yellow is limited, partial or emergency use approval. So obviously, we're using these in North America. They are using them in Europe. They are using them in Australia, somewhat in South America. Obviously, wealthier countries at the moment for the most part. So what are the key points that we saw in the Pfizer vaccine studies on efficacy? So when they released the phase 3 data, it was very good. So we saw that antibody titers were high, so in terms of immunogenicity, higher than in people who had had natural infection. And they looked This study was a large study. It was a multinational study. It had 119 sites, although, actually it had 152 sites, although 130 of those were in the US, but there is one in Brazil and 4 in South Africa, and of course this study is ongoing. People were given the vaccine or placebo in a 1-to-1 ratio. It included people who were 16 years or older, and it was 2 doses, 21 days apart. In total, they recruited almost 43,500 people. Their primary endpoint was the onset of COVID-19 disease, meaning a symptom and lab-confirmed disease greater than a week after the second dose of vaccine. And they found a 95% efficacy at preventing COVID-19 with a pretty good confidence interval there. They had a total of just 8 cases in the treatment arm versus 162 cases in the placebo arm over the short term, because remember, they only were tracking these patients for about a month or so when the results were coming out. So we're just dealing with short-term numbers here in terms of the difference. They didn't see a difference between age groups, sex, race, ethnicity, BMI, or comorbidities, which was important. And about 1/5 of the participants were over age 65, which is important that they included a significant chunk of that vulnerable age group. There were only 10 cases of severe COVID seen in this early study, which of course didn't follow people out that long at this point, and 9 were in the placebo arm. So then we go to Moderna, very similar vaccine. This was a phase 3 study, randomized, observer-blinded, placebo-controlled, 99 centers, all in the US. Again, 1-to-1 randomization, 2 doses, 28 days apart, and over 30,000 patients aged 18 or older. Again, a messenger RNA vaccine, again, a lipid nanoparticle, and again, the target is the spike protein. And 2 doses, 28 days apart. So how these vaccines work is they deliver the mRNA of the virus in this nanoparticle. It bumps into a host cell, it goes into the host cell, and it doesn't enter the nucleus, it doesn't integrate into our DNA, it starts producing the spike protein, which is then presented by the cell and activates various immune arms. So their phase 3 data, they looked at, primary endpoint was developing COVID-19 disease with onset greater than 2 weeks after the second dose. And they had a 94.1% efficacy at preventing COVID-19 disease. 11 cases in the treatment arm, 185 in the placebo group. There were 30 severe cases, all in the placebo group. And there was no difference in efficacy between sex, age, and comorbidities. And they had about a quarter of participants greater than 65 years. So again, they included a good chunk of people in the vulnerable group for severe COVID and mortality. And the map shows you where this one's been rolled out. It's approved in Switzerland, and again, North America and Western Europe are the predominant areas that we're using it in so far. So now we get to the third approved vaccine, which, as you can see, is rolled out a little more broadly, certainly, than Moderna. And this is the Oxford AstraZeneca vaccine. This vaccine is a little different, but it still encodes genetic material that encodes the spike protein, right? So the target's the same, but it uses adenovirus, an animal adenovirus vector, to get the product or the vaccine into our cells. So it encodes double-stranded DNA, which encodes the spike protein. The viral vector does not replicate in human cells, right? So you're not going to get chimpanzee adenovirus infection, right? It's non-replicating in human cells. It's just a delivery vehicle. And this vaccine is given as 2 doses, 28 days or more apart. And in fact, after I'll show you the data, it's now recommended to give the second dose 12 weeks after the first, so 3 whole months after the first. So their data is a little bit more difficult to work with, because that trial is actually 4 trials, and those trials are happening in several countries, so in the UK, Brazil, and South Africa. But they are the same in the sense that it's the same amount of viral particles, adenovirus particles, that they give to people. There have been a few knocks, especially after the first set of data, that made people pause. So a couple of those things were a little unusual. So in one of the UK studies, a subgroup of patients just got half a dose as their first vaccine shot, and then a full dose for their second vaccine shot. So they're called the UDSD group there on the slide. But interestingly, even though they got a lower dose as their first dose, they had a better efficacy rate in the preliminary data. So I show that to you on the slide, where the standard dose group, SDSD, had an efficacy rate of 62.1 of a fairly wide confidence interval, and the underdose group had an efficacy rate of 90%, also of a wide confidence interval. Now, that made people pause about why that should be, and there are still, ideas about that, which I won't get into, but it certainly made people pause. The other knock against this study, which continues to the present time, is that very few people were over 55 years of age, and very few people were over 70 years of age. So could you apply this to that more vulnerable elderly population? So they've had a second data release, and in that second data release, they actually divided their treatment arm, and they divided their treatment arm so that the second dose, which was initially given at 4 to 6 weeks, was now being given after 12 weeks to half the treatment arm, and then the other half still got the same dosing interval for the second dose. And for the standard dose grouping, with less than 6 weeks between doses, they found a similar efficacy to the first set of data in the 60s. But if they stretched out the time between doses, they got a higher efficacy at 82.4. So this was interesting, that with giving the immune system more time to respond to the first dose, you got a bigger punch perhaps with efficacy. Now, in both data sets, for people who got COVID-19 infection, all the hospitalizations, which were very few, were in the placebo group. Again, this is a younger patient population, although I must confess I didn't see the demographic breakdown for the second data release, but they didn't have a lot of hospitalizations in this trial, which is a little bit, something to take note of. So those are kind of the three we hear the most about, and we'll come back to the mRNA vaccines a lot in our discussions of some of the important clinical questions. But I'm just going to introduce a few other players here, because they're really on the cusp of entering the marketplace, and possibly and definitely big possibility in Canada. Of course, AstraZeneca has not entered the Canadian market. We just have the 2 mRNA vaccines, but it is under review. So Novavax is again targeting the spike protein. It's a nanoparticle that's studded with spike proteins. So instead of delivering genetic material, you're making those proteins, sticking them on a particle, and tossing that into the person as the mode of delivery of the vaccine. The full data for these phase 3 studies I haven't seen. The efficacy based on 2 studies, one in the UK and one in South Africa. In the UK, it was going up against a mix of kind of original COVID strains and B117, which was gaining a lot of traction in England at the time as the predominant strain. And they saw an 89% efficacy overall, which was 95.6 for the non-B117 and 85.6 for the B117. So still a pretty good efficacy for a COVID variant, although the COVID variants of concern for vaccine efficacy are more in the Brazilian and South African variant. And so in the South African study, where virtually all the cases were the B1351 variant, they had less than 50% efficacy, which they extrapolated as 60% efficacy when they excluded HIV positive patients. So certainly not bad. When people look at the data, the mRNA vaccine data, early data, is so good that everything else they kind of look at as, it's 50s, 60s, 70s, 80%. But that makes a real difference in terms of clinical outcomes. And when we develop vaccines, of course, we're all hoping for something like tetanus or polio efficacy, and we're not hoping for something like influenza efficacy. But if you get a vaccine that's 60, 70% effective, it does carry quite a punch. And so these vaccines, especially given that there's differences in strains, are going to have a place, and a big place, in initial vaccination campaigns. And that brings us to Johnson & Johnson, which is now submitted for review in Canada as well. And as of tomorrow, the FDA will rule on whether it gets emergency use approval in the States, which it probably will. So this is another modified adenovirus. This one's a human non-replicating one, which delivers DNA encoding mRNA, again, for the spike protein. Spike protein's the target. It's a single dose, though. It's the only one that's a single dose. And so that's generated a lot of, attention. The reality is we don't know for any of these vaccines what their durability is going to be like. And in adult medicine, sure, we have some single dose vaccines. They're not awesome. Could they be better if they were boosted? We don't often study that, but now we're going to have a single dose vaccine joining the fray. So when you look at the efficacy of this vaccine, they studied it in 3 different places. And in the US, where there wasn't a lot of circulating dominant variant strains, 72% efficacy, South America 66%, South Africa 57%. Although they reported efficacy of 85% across all 3 regions in preventing severe disease, which is very significant, of course. If you can keep people alive, keep people out of hospital, that's important. So they are looked on fairly favorably to move forward. I'm going to touch on the Sputnik 5 vaccine because they've released the phase 3 data. You can see it's spreading in use across the world there. And it's an interesting vaccine. Again, it's a spike protein target. Again, it's an adenovirus vector, but they use a different adenovirus for each shot for the 2 doses. And that's interesting because the premise there is your immune system is less likely to recognize the second vector if it's different from the first. So you might get a more robust immune response if you're hitting it with different adenovirus. You might get some more ancillary response there. So it's kind of a neat strategy. Their primary endpoint in the study, which was all done in Russia and involved 25 centers, they recruited about 20,000 people. 18 years and older. They did 3-to-1 randomization, 3 vaccinated for every control. They wanted to vaccinate people more aggressively. And their primary endpoint was COVID-19 cases from day 21 of the first dose, which was actually the first day of the second dose, the day of the second dose. So they decided to measure from the day you got your second dose. And they got an efficacy of 91.6%. They saw no difference in greater than 60-year-old patients, although that was only 10% of their study population if you look at the raw numbers, so low, as with AstraZeneca. And they had no severe cases in the treatment arm. So a very good efficacy rate for a viral vector vaccine. Again, not a country where we've had reports of circulating dominant variant strains at the time. And of course, this was much earlier in the pandemic. This was a vaccine that came out very early. And finally, I'm just going to touch on one of the vaccines from China, which is Sinopharm. And I'm going to touch on it because I think it's very important moving forward that we recognize that it's very valuable to have vaccines that kill the virus in different ways. And everything I've showed you so far has been spike protein, spike protein, spike protein. That doesn't mean it's not going to work. We still don't know how effective it's going to be. But as we know from our treatment, or at least our experience treating mutating viruses like HIV, for example, in terms of treatment, we tried to hit it in several different key spots at the same time, and that increases our efficacy and durability and of our treatments. So the fact that we're getting different kinds of vaccines developed with different targets is very important. So this vaccine, they've released no phase 3 trial data. As you can see, it's been has limited approval in several different countries outside of China. The efficacy is reported as 79.34%, very precise, but again, no data released to kind of have a closer look at that. So those are studies, and so if you kind of, it's a bit of a parade of numbers, but you kind of still have that flavor. The mRNA vaccines are over 90%. The viral vector vaccines are somewhere in the 60 to 90%, but then when these variants come in, what kind of problems are they causing? They seem to be causing some efficacy issues, which we're going to talk about. So let's talk about outside of studies, right? We're getting to the point where we're starting for the first time to see some data on vaccine efficacy in the real world. And Israel, of course, is getting a lot of this media attention because they've been quick and organized, and they vaccinated a large chunk of their population. So as of last week, 47% of the population had received 1 dose of the Pfizer vaccine, and 31% had received 2 doses, including nearly 90% of people over 70 years of age, which is quite remarkable. They published their data just yesterday, so I had a read of this last night. And they basically did 1-to-1 matched vaccinated and unvaccinated controls, and they really made an effort to match people not just based on age, but risk of exposure, ethnicity, geographic zone in terms of COVID risk. So they really tried to do this in a robust fashion. And they looked at the period of vaccination, which was from December 20th to February 1st. They had about 600,000 people in each arm. So of course, this is an observational study, right? But they had 600,000 people in each arm. And they looked at the efficacy after 1 dose, day 14 to 21. Remember, this vaccine was designed to be first dose is day 1, second dose is 3 weeks later, day 21. So they looked at efficacy after you had the first shot for 2 weeks, right? You were a week before your second shot. They looked at that week where you would have generated some response from the first dose. And they also looked post 2 doses, starting 7 days after the second dose. So they kind of looked at 2 different groups. One had had their first dose and already 2 weeks in, and one had had both doses already a week out from a full vaccination schedule. So what did they see, or what are they seeing? So after 1 dose, at day 14 to 21, the efficacy for preventing infection was 46%. The efficacy for preventing symptomatic COVID-19 was 57%. The efficacy for preventing hospitalization was 74%, severe disease 62%, and death 72%. Granted, the last 2 have very wide confidence intervals. Okay, and overall, a bit of stretch there with the confidence intervals. But when you looked at the full vaccinated group, they have both doses, and now they're more than a week out. The rate of documented infection prevented, so efficacy for preventing documented infection, 92%, symptomatic COVID, 94%, hospitalization, 87%, severe disease, 92%, still with a pretty respectable confidence interval. They didn't release any death numbers for that group. So very encouraging in a short observation period, but in terms of the short-term efficacy, and more good things have been reflected in that they saw no difference across age groups and hospitalization rates. So the elderly did just as well. And they saw hospitalization rates declining for all vaccinated age groups compared to unvaccinated comparators. So if you got vaccinated, no matter what age you were, your hospitalization rate was decreasing compared to the matched controls. The study population was a bit younger with less comorbidities than the entire eligible population, because they were vaccinating high-risk people so quickly and so aggressively. They actually didn't have enough people in that demographic to include as matched 1-to-1 controls. But they still included 28% of people were over 60. They actually included pregnant women, 1,508 in each arm. And they included a good proportion of people with diabetes, obesity, hypertension, and smaller proportion of cardiovascular disease. So some pretty good external kind of validity there in the numbers. And that kind of brings us to pregnancy, which of course is always a sensitive topic with new medical advances, and in a time of a pandemic, even more important. So, and I get, as I mentioned, quite a few questions on this, and I'm sure you do too. So let's talk about the data first in the first part of the talk, and then we'll talk about the other recommendations and other stuff in the second part. So let's look at the data. So what's the data in pregnancy so far, in pregnancy and women who are breastfeeding? So there's very little. So in the Moderna group, they did animal studies on pregnant rats. They saw no sign of developmental, meaning teratogenic, nor reproductive toxic side effects. So there's some animal data. With Pfizer, they didn't have animal data to present, but they've actually launched a study to evaluate safety and immunogenicity of the Pfizer vaccine in healthy pregnant women who are generally in their, looks like they're targeting that second trimester, 24 to 34 weeks pregnant. 1-to-1 randomization, target of 4,000 pregnant women. And that just launched last week. So, we don't have data from that yet. So I'm going to flip over a little bit in the data part to vaccine safety and adverse effects. We're going to come back to pregnancy in the second half. We're going to come back to some other issues in the second half. But let's talk about safety, and always a big point of concern for our patients, for ourselves. These are new products. It's a novel mechanism in the mRNA platform of vaccination. So what have we seen? So commonly seen side effects include what you'd expect, local injection site reactions and a flu-like illness that lasts generally for a day or so with fatigue, headache, muscle pain, joint pain, etc. Sometimes fever. So nothing unusual there. I've listed the ingredients on purpose, as I suspect there might be some thoughts or concerns about safety in this respect. These are actually very small lists of ingredients in these vaccines. Obviously, the mRNA is there, and of course, that lipid stability code is there. And after that, you really have things like potassium, sodium, sucrose. In the Moderna vaccine, you have some sodium, sucrose, acetic acid, cholesterol, and then you have a few things like tromethamine, which is a buffering substance, a pH buffering substance. It's included in some drugs like ketorolac, so it's not really anything exotic. And of course, you have PEG there, which we use for colon preps and constipated patients, not exactly an exotic substance either. So not a lot there to raise eyebrows, except for, of course, the novel ingredients. So let's look at some of the data around anaphylaxis and death from vaccinating people with mRNA vaccines. So this is generated in the US through the Center for Disease Control. They are harnessing their vaccine adverse event reporting system, which is a pretty robust system. It's been in place for a long time. And so far, they've seen very good safety signal. So 4.5 cases of anaphylaxis per million vaccine doses administered, and 113 deaths out of almost 14 million vaccine doses. So at least 7 million people if they all got 2 doses, but obviously it's more because a lot of these are just 1-dose patients so far. Of those 113 deaths, 78 were in long-term care patients, and all deaths were not causally related to the vaccine dose. So again, a very encouraging safety signal, massive amount of vaccine doses. If you flip over to our one of our important advisory bodies, so NACI. So NACI recommendation, National Advisory Committee for Immunization is as follows. The authorized COVID-19 vaccine is contraindicated in individuals with a history of anaphylaxis after previous administration of the vaccine, not any vaccine. Vaccine is also contraindicated in people with proven immediate or anaphylactic hypersensitivity to any component of the vaccine or its packaging, if that's known. Clinical trials excluded individuals with history of severe adverse reactions associated with a vaccine and or severe allergic reaction to any component of the vaccine. Individuals with a history of severe allergic reaction to a component of the COVID-19 vaccine should not receive it. So basically they're just saying, if you got an anaphylactic reaction with the first dose, or you've had an anaphylactic reaction to a component in the vaccine, which as I just showed you is very few, you shouldn't have it. But that's obviously, really means pretty much everybody can have it. So I'm going to introduce this slide and then I'm going to pause for some thoughts so far and some questions. We will be covering a lot more ground. I'm going to speak for probably another 20 minutes or so, which will give us about 20 more minutes for a discussion. Or actually we're going to 8:15, so give us lots of time for discussion. So some of the important questions I'm going to talk about in the second part, just in case they're bubbling in your mind and you want to talk about them now. If you can save the thoughts if you wish. So what can we say about immunogenicity of these vaccines? What kind of clinical correlates can we draw from antibody titers, for example? What can we say about vaccine durability so far, the duration of protection of these vaccines? Do these vaccines that are available prevent transmission of COVID-19 infection? So yes, they seem to decrease, and in some ways, in a big way, death, hospitalization, and symptomatic disease, but do they prevent transmission? Should we be vaccinating pregnant women who are breastfeeding, or immune-compromised patients at this time? What is the effect of delaying the second dose, which we're dealing with and grappling with in Canada? What is the effect of COVID-19 variants on available vaccines? We're going to boil that down. And what does the future look like in the post-first round mass vaccination era? So after we've done our first big round of vaccinations as broadly as we can, what is the future going to look like? Which is the big question I was asked in the hallway very seriously by a colleague, and of course is a big discussion. So I'm going to pause there, Dr. Rowan, in case there's things bubbling up.
Yeah, there's just a couple of questions that have come up. There was one question just about more of a process thing about keeping track of, from one vaccine to another. But we're not talking about process tonight. Maybe you could, I don't know if there is any data if somebody is vaccinated with one vaccine and then gets a different vaccine for the second dose, if that makes a difference, if there's any evidence or any data on that. And then the second question just is asked you to comment on the Made in Canada vaccine that's coming down the line, perhaps, and if you have any comments on that and where it might be, what phase of clinical trials that may be coming in.
Sure, no problem. So, for the first question, because yes, they are doing this in some countries. They've given a dose of Pfizer and then a dose of AstraZeneca, for example. So, what does that do? Well, unfortunately, because we're so early in all of this, we don't really know what that does. And really the pertinent questions is, what does that do in terms of efficacy in the short term? What does that do in terms of durability? If you think about it from a durability perspective, you're still introducing spike protein in both of those vaccines. So the vaccine target is the same, but you're introducing it with a different vector, right? So you're still delivering the same suspect part, you're just using a different CAR to get it there. And so theoretically, you'd say, well, you're still going to see spike protein both times. You're still going to generate an immune response against it. But then when you look at the AstraZeneca and Pfizer data, for example, you see a big difference in efficacy so far in the data. And so are you weakening the Pfizer vaccine by using the AstraZeneca vaccine, right? We don't know that, right? We only have the short-term data that we do. And so, you're certainly not boosting the immune system in the exact same way, right? And giving an adenovirus vector, if you're getting a worse immune response then through the mRNA nanoparticle, then yes, you might be causing some decrease in efficacy signal. So the data on that are not out in any kind of a cohesive way. It's too early to know that. So it is an experiment. The second question, there are two Canadian vaccine candidates that are kind of at the fore. One is out west, one is in Quebec. Medicago is the province in or the product in Quebec, and Providence Pharmaceuticals is the one out west. So Providence is an mRNA vaccine, very similar platform to Pfizer and Moderna. But they are very early still in the, they are in phase 1, as far as I know. They're certainly nowhere close to phase 3 yet. The Medicago vaccine is actually very interesting to me, and based on the point I mentioned earlier, which is that it's a vaccine that is attacking the virus in a different way. So it's forming viral-like proteins, or VLPs, which are the nucleocapsid, so the shell of the virus, right? So it's like the body of the car, but you don't have the engine inside, and it doesn't necessarily have all the proteins on the outside. But so it's gonna be a different mechanism for attacking the virus, a different way of stimulating the immune system, not just a different vehicle for delivering the same antigen. So they are a little bit further along as far as I know. But the last I heard, and I must confess I haven't had time to check up on where they're at exactly, was something along the lines of phase 3 trials. Phase 3 trial results in early 2022 or end of 2021. That's my recollection there. All that to say is, what I can say is that they're not both, on the cusp of releasing phase 3 data that's going to, go for review immediately to Health Canada.
Okay, that's great. Thank you so much. There aren't. Oh, is there any other questions? So there's a question about low-income countries will lag behind in access to the vaccines, and how do you think this will affect the length of the pandemic?
Yeah, no, I mean, it's an excellent question, and it's something that's being talked about a lot. The reality is that when you have places that are lagging behind, you will have a longer time that virus persists at high levels, meaning there will be more opportunity for mutation and more variants. So that may certainly affect the length of the pandemic if those variants show that they are worse in how virulent they are, or in how good they are at avoiding the immune response from the current vaccines. So that is a problem, and of course, as many of you have probably read, there is an organization looking at this problem, COVAX, which is a conglomerate of organizations whose goal is to get vaccines into countries that are more resource poor. And of course, AstraZeneca has been the leader in the pack for that, although some of these vaccines from China and inactivated and vaccines are also percolating through some of these countries. But the other signal, of course, that we're seeing already from South Africa and Brazil is that we're going to see more of these variants, and we're not sure, and we'll talk about that more in the second half. But the last thing I'll say is it looks like Johnson & Johnson and Novavax are going to be making inroads into some of those developing countries. As far as I know, Pfizer and Moderna have not put forward any commitment to joining the COVAX movement. I think from an outsider's perspective, they're probably struggling to meet demand for the contracts they already have with richer countries, and they probably don't even have capacity to go beyond that yet.
Okay, thank you so much. I don't see any other questions in the box there, so proceed away.
Okay, wonderful. So in this part of the talk, I will pause after each section to generate some discussion or questions. So let's start with immunogenicity. So this may seem like a bit of a lab concept that people aren't as excited about, right? Obviously, it's the first step of vaccine development is, can a vaccine stimulate a good immune response? And what does that mean? with this virus? Well, it means we want to see good antibody titers, and we want to see a cellular response in terms of CD8 killer cells, and both branches engaged of the adaptive immune response. Now, all the vaccines that we've talked about generate high levels of antibody against COVID-19, or I should say SARS-CoV-2 virus there, sorry. But the key point about antibody is we still don't know the correlate of protection. In other words, we don't know the quantitative level or the threshold of antibody that actually is protective against disease and infection. So you can put out, you see these numbers in people of antibody titers if they're naturally infected and in vaccine studies, but you don't really know what they mean because you don't know where the line is for what's effective and what's not. Certainly the higher the better, but how low is too low? So we can't really comment on the significance of vaccine efficacy or durability over time based on antibody titers. Certainly we can comment in the extreme situation where there's no antibody present very quickly after the vaccine is given. But even there's correlates that say, well, that's not the whole story because there's memory cells, there's a cellular immunity. And if you were to stimulate that immune system, it might actually give you a robust response. So it's an imperfect, it's certainly not a great correlate at all of vaccine efficacy or durability over time. Some studies look at cellular responses of the adaptive immune system by measuring things like interferon. They looked at that with the Sputnik 5 study, but that's still very much an evolution. So, when I see these articles in the media that say, Pfizer Moderna vaccine less effective against B1351 variant, and then it goes on to say that in the lab they found that the antibody level dropped, 6.4-fold or 10-fold, but was still quite high when they or that the neutralizing titers, meaning how much antibody you need to kill a certain amount of virus on a plate, were decreased, but they were still a pretty good dilution. I don't really know what that means. And obviously it's more exciting to write a media article that says vaccines are not going to work against variants than to say antibody levels somewhat lower for this variant. Scientists still don't know what that means clinically. But that's the reality, is we don't know what that means clinically. So it tends to create more consternation and anxiety than anything when you look at some of these articles. And I think there's been some really good reporting. Now I get to editorialize a bit in this part. So I think there's been some pretty good reporting by a number of sites, and they try to stay true to the facts. It's just, when they're interpreting the data or the meaning of the data, that can really put you on a path that's not accurate. So, that's one of the things to look out for. I'll pause on that one before we go to durability. Yeah,
so the only question that came into the box during that talk was just a comment. It was having first dose of Pfizer and then Moderna a second, but it's not studied. Does it not go along the lines of the Sputnik principle? If not, have I got it wrong? And
yeah,
a lot of thanks for.
Yeah, so so let's break that down a bit. So if you're giving, yes, you're delivering the same product in a slightly different vehicle, but the mRNA nanoparticles, which are both kind of just lipid shells for stability that Pfizer and mRNA use that Pfizer and Moderna use, are incredibly similar. And two different adenovirus strains, which have their own different antigens, are much less similar. So theoretically, in one case you're following a banana with a different kind of banana. In the other case, you're giving an apple and then an orange as the vehicle. It may be a poor analogy, but all that to say is that different adenoviruses are more dissimilar than lipid nanoparticles, two different lipid nanoparticles. Okay, so I'll go on to vaccine durability. I'm sorry?
Yes, please. No, that's it. No other questions, Jeff. Thank you.
Okay, thank you. So I'll go into vaccine durability or duration of protection. I mean, this is a big money question, right? How long is this good efficacy, this beautiful efficacy signal that we're seeing in early real world and trial results from these mRNA vaccines and from a few of these other vaccines, how long is that going to last? Are we going to see at 8 to 12 months what we saw with natural immunity in that example I gave of the Manaus in Brazil? Or are we going to get a much more long-lasting response? And so we want to look at post-vaccination protection in the short term, the medium term, and the long term. But we're so early in this. We just don't have that data, right? I mean, if you think about it, even from the data in Israel, which has been at the forefront in terms of a speedy vaccination, they started in December and we're in February. So we have very short real-time data. And if you look at study data, well, they have a few more months on that. You know, they're pushing 6 months, et cetera, but we're still in the short-term phase. So we don't have answers to those questions. We can theorize about it, we can speculate, we can compare to different vaccines that use similar platforms and other diseases, but we don't have the objective data. And that's not a knock against the vaccines. It doesn't mean you shouldn't get them, right? It's a big question. So in fact, there's reasons you should get them, and we'll go into that a little bit more. So if we look at Moderna and durability, so they did a study looking at binding and neutralizing antibody titers in vaccinated patients. So how much antibody you generate and how much antibody is needed to kill a proportion of virus. And they looked at that 90 days post-vaccination in vaccinated people against people who had previous COVID-19 infection. And so they found at 3 months that the levels of both binding and neutralizing antibody were preserved in vaccinated patients. And they were much higher levels than in people who had natural infection. Now, again, my previous comment holds. We don't know what the threshold of protection is for antibody titers, but certainly it's encouraging at 3 months to know that you have the same neutralizing activity of your antibody and you still have high levels of it. Again, short-term data. So I'll pause there, and if there's any comments or questions about durability.
No real comments about durability. There was a question in the box just about apparently private labs have a test available measuring antibody levels to check whether or not you really need to get a vaccine in the first place. So if you could comment on that, and maybe the other thing that kind of came to mind a bit was, you know, if somebody's had even a mild case of COVID-19, should they receive a vaccination? If so, when?
Right. Yeah, those are good questions. So, you know, let's take a step back. If somebody's had COVID-19, it's lab diagnosed, and then you go to the lab, a private lab, and you get a serologic test done, and let's say it gives you a quantitative level of antibody, you still don't know what that means. As I just mentioned, is that number good? Is that number bad? Is that number okay? And you also don't know how good your native immunity or your acquired immunity is going to be in terms of length of protection. Again, I go back to that slide where we know that with cold-causing coronaviruses, we can get them every year. And while we haven't seen a lot of reinfection, that is true after about 14, 15 months of this pandemic. We still don't know enough about acquired immunity to say that it's durable. And we also know that these variants may throw a big wrench into that, in that it might not matter that you got infected, because you got infected with the wild type strain, and now the dominant strain in Canada is, B1351. And as we saw in Brazil, and they saw in some studies I'll show you in South Africa, previous infection was not protective against those strains. People got sick again. The logic that for me that comes forward from that is, why wouldn't you add a layer of protection? Why wouldn't you boost your immune system? And also these vaccines are evolving to target these variants. So why wouldn't you boost your immune system encompassing these variants that you were not exposed to when you had your initial infection? So I really think it's a win-win situation to get vaccinated, whether you've had COVID-19 or not. You're not costing yourself anything, and you're adding on a layer of protection, possibly better even than native infection, or possibly aimed at a variant that wasn't around when you got sick. Did I miss the second part of the question, Dr. Rowan, or did I answer that?
No, I think you got that fine. There is another question in the box just about should we be concerned about the speed of making new vaccines against new strains? And second part, will it be an influenza type scenario where we're going to be getting perhaps annual seasonal vaccines based on circulating strains?
Yeah, those are excellent questions, and they're kind of driving to the overarching question of what does the future hold as we look into the crystal ball a little bit. But we can say, I think, a few intelligent things. So the first question is, how are we responding to these variant strains in vaccines and rapid development? Or are we even? I'm going to come to in a slide, so I'm gonna just bookmark that for a second. It's a very good question. The second question about will this be like influenza? So, you know, are you an optimist or are you a pessimist is kind of the one principle here. But I think we can say a couple of things. Number one is we've never had an effort at making vaccines like this. We are going to have so many vaccines that target the virus in different ways. We've also never had vaccines that we can modify quickly and re-release, which is quite possible with the mRNA vaccines that are fairly nimble to modify. Plus, we actually have the buy-in. We have the buy-in of government, we have the buy-in of private industry, we have the buy-in of the general population, and that cuts the bureaucracy and the red tape and the turnaround time. We also have never had a vaccine for influenza that started off with such good efficacy data. Influenza also mutates more readily than COVID-19, although, again, there's some other important variables there. So do I think it's going to be like influenza? No, I don't. I think it's going to be better than that, and I think it's going to be substantially better than that. But again, part of this is looking a little bit into the crystal ball, but those are kind of some of my supporting points, and I'm open to other people if they want to share other thoughts or points on that.
Just another comment. Anecdotally, some retirement home residents in Ottawa got the vaccination, have had a more pronounced reaction with the first dose.
First dose or second dose?
It said first dose, and that was the comment.
So I can't say I'm familiar with the intimate details of that, so I don't want to speak out my ear here. So, I mean, you can get reaction with either shot. The second shot seems to elicit more side effects, although still manageable. But I'm not familiar with that, so I can't really say too much.
Okay, thank you.
Yeah.
Okay, I think you're good. There's no other questions in the box at the moment. You want to keep on going along?
Okay, thank you. Okay, so let's go to, do current vaccines prevent transmission of SARS-CoV-2? Do they present asymptomatic infection? So this is an interesting question, right? We're appropriately focused on preventing death, hospitalization, a great morbidity, but can we break the cycle of transmission? So there is some study data here, although it's early on. So Moderna, in their efficacy trial, their phase 3 trial, they swabbed participants, all participants, for viral RNA at intervals. So including after the first dose of vaccine. So people, 66% less of people in the treatment arm tested positive for asymptomatic infection after the first dose of vaccine compared to controls. And they were tested twice, about 4 weeks apart, just before they got their second dose. So, you know, that would seem to suggest that even after one dose, you have less of a chance of getting asymptomatic infection. And that was also seen in that data I showed you from Israel, where after one dose, asymptomatic infection efficacy was 40-something%. AstraZeneca looked at a subset of participants in the treatment and control arm, and they swabbed them weekly to screen for asymptomatic infection in the process of getting vaccinated. And there was a 49.3% reduction in asymptomatic infection in the vaccinated group. So that they were fully vaccinated, about 50% less asymptomatic infection. So some of them still got infection that was asymptomatic, but there was a reduction. Pfizer is doing a study in Israel looking at viral load of positive swabs after the first dose of vaccine. And viral load's a correlate of contagiousness, right? The higher viral load, the more virus you have, the more contagious you're deemed to be. And so they found viral load is reduced fourfold for infections occurring 12 to 28 days after the first dose of vaccine. So even if you got infection after the first dose, there was less virus present, and the correlate is you were less contagious. But the real world data here is still emerging and still under study. So there are some studies that are examining transmission prevention, but they're looking at rates of infection in close contacts of vaccinated individuals, both pre and post vaccination. And that one example is the Panther study in the UK. So they're looking, for example, at healthcare workers and their close contacts. And before either the contacts or the healthcare worker were vaccinated, they were doing swabs on them to see, even if they were asymptomatic, did they get COVID-19? Then they vaccinate those healthcare workers, right, who are high risk of exposure by nature of their work, and they continue monitoring the contact and the vaccinated healthcare worker. Is the vaccinated healthcare worker getting asymptomatic infection at work? And also, is their close contact getting asymptomatic infection? And they're controlling that against people who aren't vaccinated, right? And they're looking at their close contact. So that's an interesting kind of way to study the problem. And then it also brings up the question is, should we care about preventing asymptomatic infection at all? I mean, at the end of the day, if we have vaccines that are going to prevent mortality, prevent hospitalization, and you just get a mild infection or you're asymptomatic, we could live with that, right? I mean, that wouldn't be too bad. I mean, you might get a cold again, like from the old rhinoviruses, and that's it. But of course, in the short term, we want to prevent infection because we want to slow down contagiousness and spread of viruses. And in the long term, we don't know how good these vaccines are going to be yet, or what is our scenario going to be. Going back to that question about, is this going to be like influenza? Well, if we can shut down transmission completely with vaccines, all the better in terms of long term. Whereas if we can't, are we going to see coronavirus kind of sprouting up here or sprouting up there, and to what degree? So that's another point that is an important question, but is something that is hard to measure and still not terribly clear. So I'll pause there.
Yeah, I think you've nailed it on your slides and your talk, so it's crystal clear for everybody, it seems.
Okay.
No questions on this.
Very good. Okay. Well, thanks for staying with me all this time, guys.
I think the next topic is going to be a hot topic issue, I think.
Okay. All right. Well, let's get to it then. So, should we be vaccinating pregnant/breastfeeding patients? So, I think the first exercise we should always go through, of course, is the usual risk-benefit analysis of getting the disease versus getting the treatment. So we have to think about what is the risk of COVID-19 in pregnancy. These are young people. They're generally not comorbid. They're not elderly. So what is the risk? How significant is the risk? The second thing we have to look at is, okay, well, what are the theoretical risks of mRNA vaccines in pregnancy? And then the third thing we have to look at is, what are the practical general risks of vaccination in pregnancy, i.e. if you get myalgias and fever, or an adverse reaction after a general adverse reaction after vaccination. when we look at the first question, what is the risk to pregnant women? We do have some data here. So this is coming from the Morbidity and Mortality Weekly Report, which is released by the Center for Disease Control in the States. And this is a study looking at characteristics and maternal and birth outcomes of hospitalized pregnant women with laboratory confirmed COVID-19. And as you can see at the bottom, it was conducted from March to August of last year. So they found out of 598 hospitalized pregnant women with COVID-19, 55% were asymptomatic at admission. However, severe illness occurred among symptomatic pregnant women, including intensive care unit admissions, 16%, which is a bit alarming to me, mechanical ventilation, 8%, and death, 1%. Now, accepting even a death of 1% in young, healthy pregnant women carrying a child, as low as a number as it is, we always have to step back and think about that a little harder. Pregnancy losses occurred for 2% of pregnancies completed during COVID-19 associated hospitalizations that were experienced by both symptomatic and asymptomatic women. So let's dig a little deeper. This is also from Morbidity and Mortality Weekly. So here's some more data. So compared to non-pregnant age equivalent women, pregnant women with who contract COVID-19 have an increased risk of ICU admission, 10.5 versus 3.9 per thousand cases, mechanical ventilation, 0.5% versus 0.3%, and risk of death, 1.5 versus 1.2 per thousand cases. These events are rare but serious, is what the study says verbatim. They have a 12.9% chance of a preterm birth compared to 10.2% in the US population in 2000, based on 2019 data of preterm births. And they have a 2.6% chance of transmitting the virus to their babies, which is very low, but that's what it is. This is more likely after delivery than while the patient is pregnant. So that's question number one. Question number two is, what are the theoretical risks of giving mRNA, because that's what we have in Canada, to mRNA vaccines to pregnant women? So a couple of things about mRNA vaccines. First of all, the mRNA does not go into your nucleus in your cells. It does not get integrated into your genome. It also gets degraded fairly quickly in the body. The spike protein, which of course is the antigen, can travel across the placenta. The feeling is currently in the literature that the mRNA particle does not travel across the placenta. This is not live virus. It is not whole virus. It's a little piece of a virus. There is no risk of getting infection of COVID-19 in pregnant women. So there is really no theoretical risk in terms of the vaccine itself. When you look at the vaccine components, I outlined them for you earlier. Polyethylene glycol is there, right? Some sucrose, some sodium, not anything to raise your eyebrows at. When you look at general risks of vaccination, the reaction to second doses in young, healthy people are not extreme. I showed you the very low anaphylaxis rate. The general reactions are myalgias, arthralgias, and headache. Some people may get a fever. These side effects are transient and they are not severe. So let's have a look. As physicians, we're often asked to advise pregnant people, and we take it seriously for good reason, and we want to be careful, and we want to give good advice that's safe. And there are, of course, medical legal implications for us as well. So let's have a look at what some of the governing bodies are currently saying about vaccinating pregnant women against COVID-19. So the Society of Obstetricians and Gynecologists of Canada consensus statement states the following. So our Society of OBGYNs: women who are pregnant or breastfeeding should be offered vaccination at any time if they are eligible and no contraindications exist. That is their consensus statement. Now, I don't want to do them short shrift. They do talk about having important conversations about risks and benefits, as we're having, but that is their consensus statement. Their counterpart south of the border says the following: ACOG recommends that COVID-19 vaccines should not be withheld from pregnant individuals who meet criteria for vaccination based on ACIP recommended priority groups, their body for recommending priority groups, not excluding groups at this time, because we are vaccinating priority groups. So that means pregnant ladies who work in healthcare or high-risk settings, or pregnant ladies with comorbidities, because that's the priority group right now. NACI, our National Advisory Committee for Immunization, says the following: NACI recommends that a complete vaccination series with a COVID-19 vaccine may be offered to pregnant individuals in the authorized age group if a risk assessment deems that the benefits outweigh the potential risks for the individual and the fetus, and if informed consent includes discussion about the absence of evidence on the use of COVID-19 vaccine in this population. A typical, prudent, cautious recommendation from NACI. I'm not going to pretend to argue there's data, there's good data, there isn't data, but I will go back to the comments I made about theoretical and actual risk of giving vaccination with these products. And finally, the CDC, Center for Disease Control, says if pregnant people are part of a group that is recommended to receive a COVID-19 vaccine, e.g. healthcare personnel, they may choose to be vaccinated. A conversation should be had, again, discussing all the risks and benefits, etc. It does not have to be with a healthcare provider. When making a decision, pregnant people and their healthcare provider should consider the level of COVID-19 community transmission, the patient's personal risk of contracting, the risks of COVID-19 to the patient and potential risks to the fetus, the efficacy of the vaccine, the side effects of the vaccine, and the lack of data about the vaccine and pregnancy. So a more wordy, more thorough, more medical legal, but nevertheless prudent statement from the CDC. So I'm going to go finally to the Ontario Ministry of Health, which says pregnant individuals in the authorized age group may choose to receive the vaccine after counseling by a healthcare provider familiar with their pregnancy. That includes a review of the risks and benefits, a review of the potential risks, consequences associated with COVID infection, a review of the risk of acquiring COVID infection during pregnancy, an acknowledgement of the insufficiency of evidence for the use of current COVID-19 vaccines in pregnant people, and if after this counseling the patient feels the potential benefit outweighs the harms, they should be able to access the vaccine. Verbal attestation of counseling, I don't know why 3-page got in there, sorry, of counseling received can be provided at the time of vaccination as part of informed consent. I'm going to pause there. I threw out quite a bit of data and at you, so some comments and questions.
Yeah, so I think there's less than I thought. I guess a lot of people are aware and going to be offering vaccinations to the pregnant population. There was just a question about is one vaccine better than another for pregnant women, or is it kind of better to take kind of what's available?
Both are very efficacious, both are very similar, both are very safe. Both lack data in pregnant people. There were between 20 to 30 pregnant women in each of the phase 3 studies for Moderna and Pfizer. I've seen no conclusions appropriately from that very small amount. These are people who got pregnant during the vaccination trial. We're going to have our first answer from Pfizer, right? Because unless Moderna catches up with the study, but as I mentioned, Pfizer's seems to be first out of the gate with doing a specific study looking at pregnant individuals. So I'm guessing, whoever gets there first will get the nod first. But for all intents and purposes, they are extremely similar.
Okay, that's great. Thank you. Yeah. So no other questions so far. So you're doing a great job explaining it. So thank you.
Oh, my pleasure. Yes, I know this is, I'll put out 2 kind of clinical vignettes from my own experience on this, because I think to speak to your comments as well about some of the stresses here. So I anecdotally heard about, a GP in southwestern Ontario who told the pregnant lady, you should not get the vaccine, nor should you have it until you stop thinking about having more children. And so, we're going to get all kinds of opinions out there. I mean, that one to me, I'm not really even sure how to dissect. It's anecdotal, it's secondhand, but I'm not even sure about the rationale other than that somebody was feeling very worried that just exposing the vaccine might somehow affect fertility or future pregnancy or whatnot. I don't know. I mean, there's certainly no data for any of that. although again, there's no data for much of anything right now, but I don't think there's any theoretical concern there. I also had a very interesting question from a colleague that I'll share with you, which was a young female physician working frontline who is pregnant and actually had COVID-19 infection in recent months and was now in the target group being offered vaccination, and was ready to remove herself from the risk environment of contracting COVID-19 in pregnancy to some extent. And the question was, should she get vaccinated at this time, right? So, you know, you got to break that down a little bit, right? So if you've had natural infection just a few months ago, you know, your antibody titers are going to be pretty good. At the time of the question, there were no dominant circulating variants, so that was not yet really on my radar, and still in Canada, where we haven't seen widespread or predominant COVID variant strains, right? And so, you know, that they have some natural protection, and we know the vaccines are safe, but do they really need to get the vaccine right now? So, I mean, going back to the previous principle and going back to the previous question, why not give your immune system that boost and give you more protection and more robust protection in pregnancy, and a very safe looking vaccine to boot? But if you've just been infected and you're going to reduce your risk exposures, then I don't think there's any emergency or urgency. You could say, I'll catch it on the second wave or you know, after I deliver. But I certainly did not discourage this individual for getting vaccinated. We had the whole talk about, you know, there's no theoretical risk. Practical risks are not high. But, you know, the wrinkle here is you've just had native infection, and so you are going to have some good immunity for a short while. Again, we're seeing very few reinfections after natural infection, especially before the variants were around, certainly not in countries where there isn't a lot of variant circulating. So, you know, so there, you're going to get into a lot of conversations like this, and at the end of the day, it's the patient's decision, but I would in no way discourage somebody from getting the vaccine. And I'll kind of leave it at that.
There was just a question before we move on, just kind of to expand on the data about COVID vaccinations. It kind of maybe speaks a bit to it, but was there data about neonatal outcomes for mothers who had gotten COVID?
Right. So there is a bit of data on pregnancy loss, which I shared with you already, and some data on preterm labor. We know that the chance of getting COVID before birth during pregnancy is not high, and as I mentioned earlier, mother to baby COVID transmission is not high in general, but seems to be more after birth. In terms of teratogenicity or any neonatal effects, I'm unaware of any signal at all. But I must say I have not dived deep into that data. However, there's certainly nothing that's come across that's been consistent or noted or of concern.
Okay, great. And then there's two other questions. One was, is there a difference in recommendations for kind of normal risk pregnancy versus a high risk kind of pregnancy, especially if you've got other comorbid? I'm just kind of perhaps speak to some of the other medical issues you're going to talk to now, you know, but a bit complicated with the pregnancy on top. And then there's another question just about, you know, trying to develop a degree of herd immunity within the family for the newborn infant, which is information on that as well.
Okay. So I'll come back to the second one in a second. Yeah. So the first question about sorry, hit me again. I got rattled. I got it kind of in the second.
Yeah. Sorry.
Yeah.
Only ask one question at a time. Moderating 101. Sorry. The so it was more about you know, is there a difference in somebody who has a high risk pregnancy, you know, yes, perhaps with other medical issues? Should they be more likely to be vaccinated? You know, to me makes sense, but yeah, your thoughts on that?
Yeah, sorry, slip of the brain there. Absolutely, yeah. So in fact, when you look at all these guideline recommendations, they do specify that pregnant women with comorbidities or high-risk exposure for contracting COVID really are the ones who should be most considered for vaccination. And absolutely, we know generally from the data that people with diabetes, people with morbid obesity, people with hypertension, people with a number of other comorbidities are at higher risk of severe disease. Doesn't mean they'll get it, but absolutely that is, if I was asked that question 10 out of 10 times, I would say all the more reason to vaccinate this pregnant person.
Great.
Yes, the second question, sorry, hit me again. Yeah.
Oh, it's just about, for should we be trying to vaccinate the whole kind of family nucleus, I guess, to protect the newborn baby, to a degree, kind of a local kind of herd immunity, if you like.
Yeah, so it depends on what the family nucleus is, and unfortunately at this point that the answer is we're limited by availability and which groups are allowed to be vaccinated in our phased rollout, right? So once that piece is out of the picture and the vaccine is rolled out to the general population and you're thinking about protecting the family nucleus with a new baby coming, then absolutely the adults, the parents should be vaccinated. The grandparents, for various reasons, should be vaccinated. The problem is with if you have other kids who are less than 16 years of age. So they are looking at some pediatric studies, and I believe Pfizer, I can't remember if it was Pfizer or Moderna, is looking at 12 to 15-year-olds, but they're kind of walking that line backwards slowly. So at the moment, people under 18 or under 16, depending on the vaccine, are contraindicated to get the vaccination, not for any reason other than lack of data. That's going to be the hang up, practically speaking.
Okay. And there was just, before we move on to the immune compromise, there was just two questions on breastfeeding. One is, will the infant get any immunity from breastfeeding? Will they get any antibodies from the breastfeeding itself? And are there any risks of breastfeeding or theoretical risks of from a mother who's vaccinated?
No, so not an expert in the field, but from a theoretical perspective, absolutely, you're going to be passing antibody and passive immunity by breastfeeding, and absolutely no perceived risk if you have active COVID-19 from breastfeeding. In other words, we don't tell women not to breastfeed. If you look at the data, again, it was just 2.6 or 2.9% in that data I showed you from morbidity mortality of women passing on COVID-19 to breastfeeding infants. The risk is not through the breast milk, even, right? Primarily, it's the respiratory spread and the close contact, right? So women are encouraged to breastfeed, and there is an antibody transfer there.
Okay, great. Thank you.
All righty. So I'm briefly going to touch on immune-compromised patients just because, it walks a similar line to pregnancy with one important exception, and that is that this is a group that may not be able to mount a good immune response. And so we have even less theoretical certainty that they'll get a good immune response here. How long will they have an immune response? And of course, it's a broad spectrum to say immune compromised people because there's so many different scenarios. But again, from a safety perspective, these are not live virus vaccines. So they're not going to harm your patient other than the usual incredibly low anaphylaxis risks, and they might feel crappy. But the question is, will they be protective? And we just don't have that data. If you look at, some snippets of data, like the one study in South Africa that, when it included HIV patients, the efficacy went down by 10%. When it excluded them, it went up against the B.1.351 variant. I don't have any data about those HIV patients. Were they well treated? Were they not? What proportion? So they did include stable HIV patients with intact CD4 counts in small numbers in many studies, and there's no reason to exclude them. really. But when it comes to people on chemotherapy with autoimmune disease, on immunologic therapy, we don't really have data for efficacy at all. And of course, we're very early in this, so we don't have medium or long-term data on efficacy for anybody. So NACI and Ontario Ministry of Health again put out statements that you can offer these treatments to immune suppressed people after informed consent and a good risk-benefit conversation, and also acknowledging that one immunocompromised person is different from another, but really hard to know how those patients will do. So what is the effect of delaying the second dose? Just being mindful of the time, I'll go through this efficiently. So we're doing this in Canada, right, especially in Quebec. And when you look at the Pfizer vaccine, after the first dose, 0 to 14 days, they estimated efficacy at 52.4%. So not great. But this was just 2 weeks, looking at the first 2 weeks after your first dose. A post study ad hoc analysis done actually by 2 Canadian authors looked at what happens in that third week after the first dose, and they estimated, looking at the original data, that your efficacy at preventing COVID-19 was 92%. But the problem is, well, that's all well and good when you're looking at 1 week. But if you left that person without the second dose, which is what we're doing, how long do you maintain that good efficacy? And is that really true that it's 92%? And how long does it stay good? So beyond that, it's an experiment, right? And just this week in the news, we heard about this nursing home in Gatineau, Laine-Allemande, where they have a recurrent COVID outbreak. They have a group of patients who are 2 months plus after their first dose of Pfizer vaccine, and 23 of them have COVID-19 reinfection. And most of them are asymptomatic or mildly ill from the media report that I read. I assume that's still true. I don't know. But and then the Quebec spokespeople for my colleagues in infectious diseases are reassuring everybody. But at the end of the day, we're still learning about what it means to delay the second dose for a prolonged period of time. If we look at another example, we get some more data. In Scotland, they've used an aggressive one-dose approach, either Pfizer or AstraZeneca vaccine. They vaccinated 21% of the population with 1 dose, and the follow-up so far is this: 5 to 6 weeks after that first dose, so a month and a half, 85% reduced risk of hospitalization. For AstraZeneca, 4 weeks after the first dose, 94% reduced risk of hospitalization. So in the short term, we seem to be able to reduce the risk of hospitalization and presumably severe disease. So there's value in vaccinating as many people as possible, as quickly as possible. When you look at Moderna, they looked at vaccine efficacy after 1 dose between day 14 and 28 after the first dose, and they found the efficacy 92%, again, a 2-week interval. So the big questions that remain about delaying the second dose is, we seem to be getting some data that it's significantly clinically protective in the short term in terms of reducing severity of disease or hospitalization at decent efficacy levels. But how long is the efficacy of those vaccines maintained after that 1 dose? How long should we be stretching people? We're now hearing 90 days. Is that too long? How long do we get that protective effect? And then the second question is, how does delaying the second dose affect long-term vaccine durability? Right? I mean, we don't know anything about long-term vaccine durability, whether we go by the study protocols or whether we go by our own interval dosing, whatever that may be. So, these are important questions that we don't know the answers to. When we look at AstraZeneca, I'll go back to that study because that was interesting. When they released their second data set, they delayed the second dose from less than 6 weeks to 12 weeks, and that actually seemed to increase their efficacy, right? And I show that data again that I showed you earlier, went up from 54.9 to 82.4%. And they mentioned that efficacy of 1 dose between 3 weeks after the first dose to 90 days was 76% in terms of preventing COVID-19. They also mentioned their mean antibody titers after 3 months or 12 weeks was about 2/3 of the peak level post-dose one at day 90. So at day 90, you still had high antibody titers, mean antibody titers. Again, I don't know what that means clinically, but at least you're preserving your antibody titers. So in the case of AstraZeneca, delaying the second dose seemed to actually improve things in this early data and early time that we have to look at the data at early time in the pandemic post-vaccine release. But you know, I think that's interesting data to chew on. So I will pause there. Any comments or thoughts about delaying the second dose?
No comments on that at all. At all. Yeah, I know we're getting close to the end of the time, so maybe I'll let you run through. There were a couple of other questions, but there's a couple of other important points you wanted to kind of finish off with.
Okay, very good. So I'll go with the effect of COVID-19 variants on available vaccines because that's important. So when we look at B117, the UK variant, we're actually, for the mRNA vaccines, we're actually seeing quite preserved efficacy so far. And that's the one that seems to be more contagious but less aggressive at avoiding the immune response. If we look at the South African variant for mRNA vaccines, it seemed to reduce the neutralizing ability of antibody. In other words, you need higher levels of antibody to neutralize the strain. Again, is that clinically significant based on the fact we don't know how much antibody is enough? If you look at the viral vector DNA vaccines like AstraZeneca, there's unpublished data in young patients who had mild to moderate disease that there's no difference in the number of COVID-19 cases in vaccinated and placebo group. In other words, in young people, whether you got vaccinated or you got the placebo, there was no difference in COVID-19 cases when you were dealing with this strain, and there was no difference in the number of COVID-19 cases in previously infected and placebo groups. So if you got native infection, you could still get B1351 variant infection just as much as people who were never infected. So that data was very disappointing for AstraZeneca in South Africa, which is why it got halted in its use in South Africa. It didn't seem to protect people for this variant. Johnson & Johnson reported 57% efficacy for the South African strain and decreased infection severity, importantly, even though the efficacy wasn't great. And Novavax reported 60% efficacy for that strain in the non-HIV subgroup. So all that to say is that some of these variants seem to be decreasing vaccine efficacy, but are they also decreasing infection, are they also preventing a decrease in infection severity and hospitalization? Well, we seem to not be seeing that yet. Now, what has Moderna and Pfizer done to account for this, which was one of the earlier questions, is they've both started exploring different boosting strategies. So Moderna's looking at 3 strategies. One is giving a third dose, a second booster dose of the original vaccine, thinking you get even more robust immune response. The second is giving a booster dose of a mRNA that's specific to the 1351 variant. And the third is a multivalent booster dose encompassing both of those in one shot. Pfizer is also exploring a third dose boosting strategy and planning to study a modified booster using a B1351 variant. So as I mentioned earlier, these mRNA vaccines are nimble and people are adjusting them and quickly producing them within about 6 weeks. To try to target these variant strains, which is very promising how quickly we can respond and how little red tape is present in approving these variations on these vaccines. And that takes us to the last point about what will the future look like after we've vaccinated a whole bunch of people. And so there are a lot of variables. There's the variable of vaccine uptake. Will we achieve herd immunity nationally, internationally, ever? Will we have good enough vaccine uptake? What will be the effect of viral mutation in terms of immune evasion and reinfection after you get vaccinated? How will that affect durability of vaccines? How will we optimize vaccines? Will we require more booster doses? What interval? Will we require modified booster doses? As I mentioned on the last slide, Or should we be giving people multiple vaccines of different types, so we're targeting different parts of the virus, and if so, in what fashion? So far, the only collaboration between two different vaccine groups has been between AstraZeneca and Sputnik V from the Gamaleya Institute to test a combined adenovirus vector vaccine construct. But we might need to use multiple vaccines in people eventually to get where we want to be. And so this is the last slide, which is putting it all together and kind of encompasses everything I just said on the other slide, except for perhaps some comments on vaccine hesitancy. I'll stop there and open it up for the last questions and thoughts.
Yeah, no, thank you so much. And it's been really informative and really helpful. There's been a lot of very positive talk in the chat box, and thank you for your really great way of presenting all this kind of complicated and data in a way that makes it meaningful for us all. So thank you so much for that. I'm conscious that because of our technical issues to begin with, we're running a little behind time, and I realize that people have lives beyond listening to COVID vaccine talks and us. So I just want to say to those who have to leave, please keep an eye on your inbox. There will be a survey that will come out afterwards that we're looking for feedback, both for this talk, but also to be questions about other topics as well. We really want to get your feedback to make education events like this as helpful and as meaningful as possible. So please do answer the email when it comes in. So if people want to stay on, there are a couple of questions about a variety of different things. Are you okay for a few minutes to kind of run through a couple of questions?
I'm fine. The children are tucked in. Grandma's over. I'm good to go.
You're good to go. Okay. So there was a couple of questions that are kind of about a few different things. There's one about, is there any risk from the vaccine itself inducing an immune storm that seems responsible for some of the severity of the natural infection?
A new storm, I missed the last part.
The immune storm that seems responsible for the severity of a natural COVID infection.
So I don't see how that would work theoretically. I see. So if you get, I think what the question means, if I'm interpreting correctly, is if you get vaccinated and then the vaccine doesn't work and you get COVID-19, might you have a more kind of a systemic inflammatory response because your immune system is responding that much more robustly? Is that kind of the flavor?
Yeah, I think that's probably a good interpretation of it.
Okay. Yeah, I mean, that's an interesting question. I'll say a couple of thoughts that come to mind. One is that if you got the vaccine, then chances of you getting severe COVID-19 are actually the reverse, because you're able to shut down the virus much earlier in the process. And as we understand the pathophysiology of COVID-19 infection, we have kind of two stages, right? We have the first stage where the virus is doing its bit, and then we have the second stage where the immune system says, uh-oh, and completely throws us into an unstable inflammatory state. So if you nip the first stage in the bud, or you nip it early because you have that adaptive immune response that's robust already, then you would think you'd avoid going into that immune storm phase. So I think I would kind of present it that way.
Okay, and I think maybe some of the other ones have kind of already been addressed already in the talk, but I guess the last question we might ask you, if you're given a choice between one vaccine or another, which one would you choose? Is one better than another, or would you say, I'll take whatever's coming?
Yeah, I think it's a great question, and I kind of expected it would be asked, and I've done some pondering about it. I mean, we all instinctively are going to go for what gives you the highest efficacy with the data that we have. So instinctively, I'm going to say I'd take an mRNA vaccine from Pfizer or Moderna, and I don't care which one because they seem very similar and they both seem to work very well. Furthermore, they seem to be a little bit more robust in terms of protection from the variant strains that are circulating. That is not known yet, but certainly because they're limited to North America, for the most part, we haven't exposed them to some of these variants in a real test, but they seem to be a little bit more durable. And importantly, they seem to be quite nimble as I mentioned, with modifying that mRNA molecule to incorporate different strains, and the production lines are there to make that happen quickly, and the buy-in in the US and in Europe where they're produced is high. So they're adaptable in terms of producing modified booster doses, which may be useful. I don't want to throw the other vaccines under the bus, but that's my human gut reaction at the current time. I think we have a lot more vaccines that are going to come out. So, you know, if you talk to me in 6 months or a year, we may be having a different conversation.
That's great. Thanks so much. And again, I really appreciate all your wisdom tonight. I will say for those still on, this has been recorded tonight and will be available on the website. I put it in the chat box with toheducation.ca. So it should be available by the end of next week. So if you felt this is worthwhile looking at again, please do. If you want to pass it on to your colleagues who weren't able to make it tonight, please share it widely as well. So with that, I'm just going to say thanks again to for all your great talk tonight, and thank you to all for your patience getting on. And we hope to be reaching out again with another great educational event in the near future.
Thank you very much for moderating and inviting me. It's a pleasure, and you know, we're all in this together, and I think we're on a much better trajectory than we were 6 months ago. So I'm sure there will be hurdles, but I'm an optimist, and I think we're going in the right direction.
Okay, take care.
Okay, have a great night, everyone.
Bye-bye.